Hi everyone, thanks Ben for the intro. I'm Tobias. I work at Argon Asset Management. We're like a fund manager in Cape Town, in Claremont, investment manager, and this is a sort of side interest that I've been involved in an open source project that I've been involved in for 1.5 years. And I have a whole slide deck, but the last time I gave it took 11 minutes, and I've only given 5 minutes today. So that presentation is online. If you search for PRQL with my name, it's 11 minutes, so you can find that. But what I thought today would be more fun is just to go through an interactive example. So PRQL stands for the Pipeline Relational Query Language, and it's like a modern replacement for SQL. And we compile to SQL. And if you go to the top there, so prequel-lang.org and then /playground, there's an online playground that you can play with, and I'll show you that right now. So the first thing in prequel, so pronounced prequel, is that we start with the from clause. So if you know SQL, and you can see on the right hand side, so on the left hand side is your prequel, and on the right hand side is your compiled SQL. And then we also actually, there's a data set that runs in the browser with DuckDB and WASM. So we can switch back and forth between the data and the compiled SQL. So yeah, we start with the data set, and prequel is a language for data transformation and analytical queries. And you can comment out each line. So if you uncomment that, this recompiles, and now we've got some updated SQL here, and our query results changed, so nothing much here yet. But prequel is all about ergonomics and sort of micro features. So you can have trading commas taken away, it doesn't change it. So it's not like if you've ever dealt with frustration with SQL, you'll know what I'm talking about. And it's in prequel, each line is a new transformation. So for example, we can filter our data set, and you'll see that we compile to some SQL here, and now we've only got the subset of the transformations, and then let's say we want to do another filter. So there, you can have them separate lines, and it cleverly combines them and produces like an AND clause here. Then we can also group, split our data set into groups, and then produce an aggregation, and it will produce a group by your SQL, and you'll see the query results here. So this is the data set of invoices. So if you wanted to look at the, so it's a data set, invoice ID, customer ID, the invoice date, and various bits and how much they paid for, etc. So let's say we want to be grouped by customer, and we'll see how much did we earn from this customer, and how many invoices did they generate. Once you produce that here, and one of the nice things is that it's each line is a separate transformation, and you can just comment out or uncomment lines, and it's very easy to build up pipelines that way, which is just not straightforward if you look at the SQL on the right hand side. And to appreciate some of the finer points, you need to know SQL a little bit. But let's say these filters were before a group statement. Now let's say we have a filter after a group. So let's say we had query results here, number of invoices, and let's see only customers that have more than one invoice. So we do that here, and great, we filter out customers with one invoice. But in SQL, you'll see that actually that generates a having clause. So it's before normally it's a where clause if you want to filter after a group by its having. So it's a lot of these things that make SQL difficult to learn for beginners. Whereas in prequel, it's all kind of logical and consistent and straightforward. And you can see here that at the bottom that having clause coming in and out. We can join on another table with some more customer data, and then let's say we want to derive a new column, and we have lots of convenience so if strings in Python. So if you want to combine multiple columns and produce something like the full name based on the first name and last name, you can just you have your F string here. We have little escape hatches for if you something that isn't in prequel, that's just in SQL, you can use this S string, which stands for raw SQL. Now let's select only a few of the columns here, and then obviously we can sort. Now we will sort by income increasing. So add this line here. Well, we're going to take the first 10. And now you see we've got this nuisance column of customer ID here on the left-hand side. So we also, there's like a syntax where if you want to exclude a particular column, you can use this exclamation mark operator and exclude a column. So this example, I've just slightly modified it. I might put a PR in actually, because I think my example is slightly better than what's on the website. But if you go to the Pre-Built Playground, that's pretty much the exact example that you'll find on there, and it's heavily documented, so you can probably just learn most of the language just by going through the example. And just maybe, I don't know, how much time do I have left?
I'll give you an extra minute.
Okay. I just want to jump to the end. So yeah, go and scan the QR code, get the website, check it out. It's an open source project. We've got 8,000, or actually close to 9,000 stars on GitHub now. We'll never monetize, and it's completely open source. We merge PRs quickly, and just maybe if you look at our chart, so GitHub stars in red, it's like it started in January 2022, and we've rapidly kind of grown in popularity and overtaken other things like whether it's Iceberg and eFlyer and something. So yeah, that's pretty cool. Come check it out. I think I got involved because I needed it for my day job for the analytical data transformations that I do, and it's been a joy to work with. So yeah, try it.
Okay, who knows what text indexing is? No? Okay, yeah, cool. I'll give you a quick overview. So if you're unfamiliar with the concept, you can think of it as the technology that allows you to type random words into Google and get back an ordered list of websites that are sort of related to the words that you typed in. So essentially you take a lot of textual information and index it, much like you'd create a database index. So my plan was to index the entire Wikipedia, just so that nobody could dispute my indexing powers. Enter Bluge, an API for indexing and search written in Go, making it awesome. And then Wikipedia, the free encyclopedia, also known as the biggest set of text documents that I could think of. So some stats about Wikipedia: if you download the database, it's about 22.3 gigabytes of bzip2 XML, not fun. 58 million pages in the database, the majority of which are redirects or templates, and then 6 million of those pages are actual English articles, like the ones that you guys would go read up on. So if we have a quick look at the data, it's not very hard to work with, but if we pull the first 100 lines out of the database, you'll see it's a bit of an XML mess. The first, let's see, okay, there we go. So the first batch of data here is metadata, which we don't care about. There's exactly 607 bytes of metadata before we hit the first page. Write that down, we're getting back to it. The first page, accessible computing, you'll see is actually just a redirect to computer accessibility. So it's not an article, it's a redirect, which is why it's text content. I can't see the text. There we go. Text content is very, very minimal. This is pretty much it right there. The second page is anarchism. It's quite a page turner. You should go read it. That's a joke. This is an actual article, so you'll see that its text content is quite a lot, and that's probably cut off about a quarter of the way through because I just pulled the first 100 lines from the database. Okay, let me get back to there and find my mouse. So whenever I explore large data sets, I start by taming the data first. In this case, I simply wanted to get the line count, page count, redirect count out of this XML dump. We're not even thinking about indexing this database yet. That would be crazy. So my first attempt at just getting that data ran for about 45 minutes. Ouch. Not good. This data is effectively not usable. I also tried to get an estimate of how long the indexing would take at this point, and it got to about 14 hours. That was my estimate. I did not verify that. Okay, bzip2. It's actually quite a cool compression algorithm. Meetup allows you to write your compressed files in chunks or multiple streams. In Wikipedia's case, each chunk or little block there would be about 100 pages. You can think of each of these chunks as a standalone Meetup file, and they all get concatenated to form one big Meetup file. So when looking at this picture, your brain should be screaming at you concurrency. But we can't just randomly hand over these chunks to different threads to start reading, because we need to know where the starting points of them are. So that is why Wikipedia provides you with a file called Meetup multi-stream index. So if we pull the first, let's see, if we pull the first 10 index entries, you'll see that we see accessible computing and anarchism right at the top. And you'll also notice 607 bytes. That is because there's 607 bytes of metadata before the first page starts. So by this logic, if we want to get the bytes offset of the second stream, we need to go to the 101st page. And that is exactly the case. If you see the 101st page, you'll see it's artificial languages, and it is bytes offset 677813. So now we have a way to actually hand off chunks of this XML Meetup file to different threads to process individually. Let me find the last one. There we go. So after I implemented the concurrent implementation and ran it on my 16-core MacBook Pro, it ran for about 5 minutes. So massive improvement. If you do the maths, you'll figure out that there's actually a bit of processing left there. I should have got into about 2.8 minutes. Definitely some memory allocations I could reduce to speed it up. So the fun part, building the index. As I mentioned, my first attempt ran for about 14 hours, or at least would have ran for about 14 hours. My second run through with concurrency ran for about 50 minutes. It's 5.50. This is just a quick graph showing the run through of building the index for the entire Wikipedia. This flat line in the middle, I'm not 100% sure, I didn't go verify what caused that. My guess is that Merge at that point actually had to repartition the entire index. So it hit a standstill for about a good 10 minutes or so. So, what's the point? This is all very boring. What can we do with this? We can match the entire Wikipedia on my laptop. If we search Drinkers Duplessis, we'll get some UFC articles with their IDs. You'll notice UFC 297 is not there yet. This database dump is about 2 months old, so it should be there by now. If you don't believe me, please come play around afterwards. You can literally search anything. The article ID will pop up next to it, and that is all happening right here on my machine, the entire Wikipedia. Quickly, further improvements, absolutely. I left quite a bit of performance on the table. Firstly, Go's XML and marshalling uses reflection, which I think eats up about 20% of my current performance, so I could definitely cut down on the time a bit more. And then, of course, we could just run this on a bigger machine. As far as I could tell, I believe it got back to the slides. As far as I could tell, doubling the amount of cores that this program runs on doubles the speed, which isn't always intuitively what would happen, but in this case it does seem to be. Yeah, that's it. I will be posting an article covering more of the business use cases soon, so if you are interested, come give me an email, then I'll ping you. Yeah, enjoy.
Computer vision is one of the fields that I love the most, really, because it's interesting, it's relevant, things that we do every day. I mean, we've gone past traditional programming, that's what I think. And AI really brings you that level, that extra layer that really allow you to interact with your environment without having rule-based programming. And then computer vision is something that's very interesting, but based on my topic. What if you could combine computer vision with LLMs? That eventually gives you something that your system could see and that your system could eventually understand and interact with you, speak with you, and you're speaking with it, and that becomes your AI agent. I build a lot of AI agents, but for this specific demo right here, Microsoft just released, for example, AI vision just now, not long ago, if you guys check the news. But then I was trying to put up a demo on something for now, but just ran out of time, I couldn't. So what I did, instead, we have, let's imagine that, let's look at this video that I have here. Let's imagine that you're a security company and then you have a footage of a breakage happening somewhere. And then the footage is like 3 hours. You just do not have time to sit and find out what happened where. But then what you can do, you could eventually use artificial intelligence to be able to tell you what happens into a specific video. But here we're just gonna take one of these random videos.
Hey everyone, it's Kenji, and I'm going to show you how I marinate meat.
For those that are interested into cooking,
So I
it's just a video on cooking, and the guy is just talking about
explaining
how to
important it is to wash meat before you marinate for stir fry, and people ask me why and how you do it. So
what you're gonna do eventually, we're piping this video.
so the idea here is that by cutting against the grain, you're shortening.
What we're gonna do, taking the video, we're gonna eventually analyze that video from a specific section, let's say from 50 seconds and 30 second later, right? So what we do here, I wrote a piece of code where, of course, I'm using some LLMs, and then I'm ingesting the YouTube video. I'm not gonna rerun this because it's gonna take a lot of time, and we only have 5 minutes. So we can ingest a video, any video of your likes, right? And then you eventually extract. You can specify. So once you ingested the video is eventually read. And eventually, after that, what we can do, we can eventually extract relevant frames of that video into that specific time-bound window that you're interested in analyzing in that specific video. And now your LLMs, what your LLMs will do, it's eventually able to go through that video. I'm actually looking for that part where it's able to go through that video and eventually, it's eventually able to go through a specified 55 seconds and 30 seconds later. And then you're able to go through the video and analyze that video and start extracting frames. Your LLMs now start extracting frames of what's happening in that video within that time bound that you specify. So now, that being said, now after having done that, now because LLMs is a different type of AI, not traditional machine learning, it uses transformers, right? Transformers understand context, it's not like pattern recognition and all of that. So now, based on that, we'll be able to also get, if you want, an audio transcription. That's 5 minutes, I still have my 1 minute, right?
No, that's 6 minutes.
Okay, so you can still have the transcription of your video during
so that they are just tough.
Specific section.
There are some times when you want to.
Based on the transcript of that video, what you're able to do now is eventually pipe your LLM so that it's able to hit your eventual model, so that your model now is able to understand what happened there and bring you back an explanation, a summary of what took place. And what I wanted to do for today was to eventually show you a demo of how to interact with it, but ran out of time. Was just too busy at the office. But then here what we'll be able to see is the LLM eventually explaining to us what happened during that specific period of time. So it summarizes for you the key points. Let me see. It summarizes for you the key points of what took place within that specific video. And it's able to eventually respond to
a person demonstrating the slicing of meat on a wooden cutting board. The speaker is explaining a culinary technique where meat is cut against the grain to shorten muscle fibers and prevent toughness, which is generally preferred to ensure tenderness. However, they mention that for certain dishes, such as Sichuan-style dry-fried beef.
As you can see here, your LLM is eventually able to go into that video, into that specific time bound period that you specified, and explain and summarize to you what happened. And you can imagine the large amount of use cases that you could get for that. It can be used in security where there's a break-in, you use computer vision to detect breaking and then have an LLM agent explaining that to you, and eventually reporting the actual situation that happened within that scenario at that specific time. And I think I'll stop right here. I just wanted to show the importance of combining computer vision and LLM, because that's your system having eyes and ability to understand context. And you can build amazing stuff that is extremely fun.
Today is Bringing AI to Life, a multilingual virtual lecture with synchronized speech and mannerisms. Now, just a bit of introduction towards myself. As mentioned before, my name is Shaun and I'm a computer vision engineer working under Joseph at Isotron. Now, the reason for this topic today is because this is a project that we have started to look into there at Isotron, and it's something that I'm really interested in, something that seems very cool and we'll be able to solve quite a few problems in South Africa. So, just as a high-level overview of what this is about. So, one of South Africa's biggest problems is that not many South Africans has the financial capacity to be able to afford high-quality education. And one of the other problems is also because South Africa is so diverse, there's 11 different official languages. Now, because of this, it's quite often the case that you wouldn't be able to find course content that is in your home language. So it would of course be ideal for you to be able to actually have your listen to your course in your own home language. And it would also be ideal if you could have detailed assistance 24/7 any time of the day. So as a summary, we need to find a way to allow access to skilled lecturers at a low cost to all South Africans that is available any time of the day. Now, our solution to this was to create a AI avatar that will be able to present the course contents to all 11 different official languages in South Africa at a low cost. So this is quite a difficult thing to do. Now, here's 4 of the main problems that we were able to identify. So one of these is the AI must be able to speak in 11 different languages. Now, this is pretty difficult, especially in South Africa, because some of the languages aren't as widely known. So there's not as much training data for this. Some of the other problems is the AI must be able to present the course content with synchronized lips and facial movements, as well as some mannerisms. The other problem is that the AI must be able to view the classroom and be able to react to them as if it's a real lecturer. So if someone puts up their hand or if people speak among themselves, the AI must be able to react based on that. Now, the biggest problem that we're facing here is that all of this is feasible and is possible, but it's very difficult to do all of this in real time. Now, that is the main difficulty and the problem we're trying to solve here today. Now, just as an overview, I wanted to provide a few examples of how one would actually be able to create an AI avatar. Now, just something that is pretty important to note. You see here at the top left, on this actor's face, there's a few green dots. Now, those we call facial landmarks. Now, that's pretty relevant in all of the methods that I'm about to discuss today. So, with the first method, this is a method called facial motion capture. So this is a method that will be able to provide very accurate and realistic animations. And it is one that was created or used in the movie Avatar. And if you guys ever saw that, it was crazy accurate. It seemed very cool. So basically, you would have an actor with all of these facial landmarks drawn on their face, and those facial landmarks would be tracked and then mapped onto an virtual avatar. And then that is how we're able to create a very accurate AI representation or avatar representation of the person's face. Now, the problem with this, it is very computationally difficult to actually do. Very computationally, it takes a lot of compute, so you wouldn't be able to do that really in real time. So the second method would be a deep learning model. So we would basically take these facial landmarks, feed that into a neural network, we would train the model to be able to predict where the person's facial landmarks would be, given the words that they're saying, along with the emotion that the AI is actually supposed to mimic. So this is also pretty cool, but it's also pretty processing intensive to do. Now, the one way that does seem pretty cool is something called phenome-based lip syncing. So just to give you a bit of introduction on what a phenome is. So a phenome is the smallest unit of sound in the language, something like a p or r, for example. So if you actually think of yourself while you say the letter O, for example, your lips would be rounded. Now, that is basically the phenome. Now the phism is the visual representation of that phenome. So if you say the word or the phenome O, your lips would be rounded. Now we would basically take that type of information, the facial landmarks on the person's face, we would take that and then map that onto a virtual avatar that will then be able to have synchronized lip movements while the AI is actually presenting the course content. Now, the reason why this is most promising, it is not as accurate, or it doesn't provide as realistic images as the previous two methods, but it is one that would be most realistic to be able to operate in real time. Now, just to give you guys an idea of just about how this might look, now this is a very high level flow diagram of how this might look, but we would basically take the course content, break that up into all of the separate paragraphs. Then we would use the landmark calculations as well as an emotional analysis. So the emotional analysis is simply to be able to tell the AI this is the emotion you would actually have to present. And then we would take all of that information, feed that into a facial landmark calculation to be able to calculate where the person's landmarks would actually be. And then we would feed that onto a mask on the avatar. And then this is what you would see there at the bottom left. Now, as you can see there, the avatar would also have to view the classroom itself. And then basically what would happen is if anything happens, the person puts up their hands, they speak, whatever that might be, that visual information will be compressed, sent to an API call via to something like OpenAI, and then the text will be received back, and then the entire process can go on from that point. So then you'll have a real-time interactive AI that will actually be able to present the course content. Thank you very much.
So I was hoping to use the subtitle for Fun and Profit, but unfortunately Ferdinand had already chosen that, so I changed it to Entering the Matrix. Yeah, what I'm hoping to show today is that modeling and simulation can be quite accessible, fun, and applicable to a lot of industries. We've already seen some machine learning models this evening. I think like seeing a software model come to life is sort of the same experience as your experience of playing with like a Tamagotchi. And if anyone recognizes the GIF, we'll talk a little bit more about it at the end. So first question is like, what is a system, right? So you have software systems, you have systems in nature, you have many different types of systems, and it's basically a whole bunch of interrelated components, and they work together according to sort of a set of rules with some sort of common objective or goal. And yeah, you often hear this idea of sort of complex systems, right? So systems are complex, and this means that there are a lot of systems that are very difficult to understand or predict without applying a sort of certain way of thinking or methodology. So people say that something is complex if the whole is greater than the sum of its parts. So that means there's sort of emergent behavior that is not true of any one part of the system, but only sort of evolves when combined for the whole system. So the Earth's climate is a good example of this, right? There's a lot of different interacting parts, and it's not it's not simple to understand what's going to happen, for example, in today's weather. So some of the world's biggest problems are because of complex systems: climate change, financial instability, UN Sustainable Development Goals. These are all related to very complex systems that are very difficult to solve for. So I think, appreciating and understanding this complexity is probably one of the first steps to trying to meet and solve, or at least manage some of these UN goals that have been set out. So models help us to understand systems. There's quite a common quote, it's probably often misquoted, but all models are wrong, but some are useful. And I think that's quite a good way to think about it. They're a simplification of reality. They sort of give you a useful perspective on a system. They are not meant to sort of be a digital twin or accurately represent the system. You get physical, mathematical, conceptual models and machine learning models, and they apply it in fields of diverse economics, physics, natural sciences, and we've got one or two models at the end that are also shared amongst them. So yeah, models are the basis for simulation, right? So models, if models are the rules, then simulations are the experiments that you run. You run them through various scenarios, you try to observe the outcomes, and you're trying to see, what are the characteristics of the system. And you're able to ask, what if questions. In a certain scenario, what would happen if you changed a certain input in the environments which the model was operating. So I think, simulations are quite like games. That's why I said they're quite fun to build yourself, and we'll hopefully get to a sort of example of that. They both have rules, exist within an environment, have a state update loop, concept of time, and rely on pretty high performance computations. And we'll find some models at the end that are almost game-like. So I think they're a great way to learn a new language. If anyone can guess the 4 languages here, come to me afterwards. But these are sort of 4 different representations of a modeling framework or simulation. And I think it's a great way if you want to learn a new language to try and implement it in that language. It's challenging to get sort of optimal performance. They can be easily tested for correctness and various things like that. A lot of the modeling work is not actually in the software itself. You've seen some diagrams that were presented in the previous talks. A lot of the work is actually in mapping out the system. So the various ways you can do that. And there was a diagram here that directly maps to a sort of modeling framework, but in general, these ones you can use to understand any sort of complex problem. So it doesn't have to be complex. These are 2 examples of very simple models and simulations. All you need is a model, time steps, how many time steps it runs for, how many times you want to run it if you're doing like a Monte Carlo simulation, for example, and some way to interpret the results. And I've got a minute left. So we've got a system dynamics model here and an agent-based model. And the results of the model simulation. So you can see you don't need much to get to some sort of interesting results or start playing around with different ideas that you might have. Conway's Game of Life, it's an example of a complex system. I think it's quite a good one. Seemingly simple set of rules that results in very complex behavior. And you can also play with those rules in starting positions. Another good example is the Volterra equations or predator-prey model. It's actually initially applied to chemical reactions, then historically was applied to natural populations, and also very widely used in economic theory to see like a market with several competitors. And not all fun and games. This was a crypto DeFi protocol. Unfortunately, didn't make it, where the model was built after the fact, but it was a complex system and probably should have used the model. That's it. If you want to learn more, you can check out the repo for this code that I showed earlier, and there's also some sort of free and open coursework that you can use to learn more about the subject. Thank you.
So my name is Munyaradzi, as you can see. I'm a software developer and graphic designer. I'm here to speak about the journey into mobile development, right? So the first thing I want to speak about is the apps that I got in development. The first one is called Connect Ease. It's an app where you can save contacts on your phone without them being accessible to other third-party apps like WhatsApp, Facebook, Twitter, whatever it is. So you can contact your contacts from that app without them being seen by other apps, right? In case you get like weird, follow this person that you apparently have the contact on your contact list. And then the second app is CodeQuest. So CodeQuest is an app, it's kind of a theory for now. It's an app where you learn coding through a game. So you basically just press on pre-typed sets of code that allow you to achieve certain goals in a game, right? So if you achieve the goals end, you win the game, and then you learn how to code and all of that. So it's a bit of a theory, that's why it's all highlighted in blue. But the apps that I got in production are Tic-Tac-Toe, which is a tic-tac-toe game, Neon, which is in neon colors. So just think of a random tic-tac-toe game, but in neon colors. And then the other one is called do more. So do more is like a to-do list, which is like typical for any developer to do. But the thing is, I want to integrate this with Connect Ease, which means that you will be able to schedule tasks before time. And then if you're a salesperson, for example, you've saved a couple of prospect clients, you can then say, okay, on this day I want to contact this client on the other app called Connect Ease. At this time, these are the notes. This is what I want to say to them for on and for off. And then I'm so sorry I'm going so fast, but here I'm going to go a bit slow. So I want to talk about my process of how to get an app from development to production. So I already introduced 2 apps that are already in development and 2 apps that are in production. So I want to take you from development to production, right? So the first batch of steps that I take is testing and debugging. I forgot to add writing code, testing and debugging, because you have to write the code as a developer. So you write the code, you test it, you debug it, and then in between testing and debugging, you can also do performance optimization. So which means you can test the code, see how fast it runs and all of that, which function takes too long, blah, 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 blah. And then security review, I use Expo, because Expo is now it's more expected for you to use Expo when you're using React Native. So I use Expo for security review because they are the ones that take all of your code, they compile it into a file that you can upload on Amazon, Google Play, Hawaii, App Gallery, whatever it is, right? So they will do all of that. If there's anything wrong with your code, they will tell you. Code logs, so those are the code logs. They will tell you that, okay, something went wrong, these are the code logs, read through, go through over your code. That's why you have to go back to writing your code, testing, debugging, performance optimization. Sorry, I'm going too fast, but if you want the notes, I'll send you. So user acceptance and testing, right? So these are some of the crazy reviews I've gotten from users. Because when I develop an app, I always ask certain people like, yo, I'm developing this app, can you test it for me? Can you test it for me? Can you test it for me? Can you test it? That's the wildest one, right? So I told this girl that, look, my app is available on 3 different platforms. She was like, oh, nice, man. Finally, I can complain on different platforms. I don't know what that means, but we move. But anyway, so these 2, I put them in the same bracket because privacy policy and compliance have something to do with your submission and approval. So if your app doesn't sort of appeal to the privacy and policy compliance, they won't approve your app, right? So it's very important for you to go through the docs, read like what do they expect from you in terms of what data you're collecting, how does it affect the user, how does it affect you, and all of that. So I just created a simple chart where my app got rejected about. Both of my apps got rejected 4 times at Google, 3 times at Hawaii, and Amazon. Amazon is easy. So if you want to build an app, just send it to Amazon. They'll be like, it's fine. So release planning. As you can see, I don't have much. I don't really have like a plan. I do plan, but the thing is, even if you have the same problem from yesterday, the next day when you wake up, look at the problem, you have a different perspective about that problem. You won't see it the same way you saw it yesterday, if you understand. So let's say it's optimization, right? I'm writing a piece of code, and then I see that, okay, I'm iterating through the same object twice, whereas I could have iterated once and then just store that value in another object and then just check if that value exists or not, you understand. So so it just depends on you. And then monitoring and analytics, user communication. I also put this in one bracket because they provide you with a developer console or dashboard, right? So Google, Hawaii, and Amazon, they will provide you with a certain dashboard where you can see how many people have downloaded your app, how many people have rated your app, how many people have sent reviews. You can see, oh, we hate your app, it sucks, whatever, it's that. So moving on, I have my dashboard. As you can see, this is for the to-do list app. So people aren't a fan of that. That's why you have that rate going down, rate going down. The next app, people actually like the tic-tac-toe game. I'm surprised. So we have a bunch of graphs, things going up, green graphs going up. That's good. I like that. So I'll work on this one much more. And then meet the team. So this is the team. Yeah. So this is the post-launch support. So after you post your app, it's been approved and everything, feedback that you get, it comes back to the team. Whatever problems you have, it comes back to the team and everything else. And then again, I have something segmented in one row. So when it comes to marketing and promotion, I use organic social media marketing because I just started out. Hence, I said beginner's journey to app development, right? It doesn't mean that you have to be the best at what you do. Just go for it. And then whatever you do, just do it. So marketing and promotion, I just use organic. I just post. So my close friends will either like it or not like it. If they like it, then I'll see, okay, this particular post, they like it. Why do they like it? And then I build on that. And then gathering user feedback, meeting people, friends and family. That's very important. Like I've met you guys, you've heard about my app. I hope you guys will download my app. I'm just saying. But otherwise, I prefer intimate feedback where you tell me face to face, like, look, you see your app, when I do this, it doesn't do this, I expect it to do this, or it does this, which is great, improve on that. And then that's that. And then I'll leave you with the quote. Software is a great combination of artistry and engineering. The reason I like this quote is because I've been in graphic design and then I moved over to software development. I've been doing software development, but I moved over to it as a career from graphic design to software development. So I kind of have both of the best of both worlds. So I can understand that from a development process, it takes much longer to deliver a product, and then from a designer's perspective, it takes also longer to produce a product, right? So you have to stand in the middle ground where you're like, okay, you have this criteria that you're giving to us. You want like when you click on the button, the man must jump over the moon, go under the moon, go over the sun, go this way and that way. But when you think about the developer will tell you, look, it will take me this amount of days to accomplish this task, right? And then you have to be extremely realistic, but at the same time, you have to listen to your client, because your client will tell you that, look, I want this thing done in 2 weeks, whereas your developer is telling you, according to the design, I can only do it in like 4 or whatever months, and then the design is like, but it took me. So you sort of get the middle ground and you manage to push apps faster. So I'll leave you with that. So the main thing that I want you guys to know is that, like, look at me, look at what I've accomplished. I've went through it like quickly, as fast as I can. So anyone can do it. You will meet failures, you will meet, like, I've been rejected, my app has been rejected a couple of times. I was like, okay, it's fine. And then I move on. So anyone can do it. So if you have any questions, just come to me, like, yo, how do I push my app? What is the first step? This is where I am. How do we do this? Thank you very much.
So, I'm Dieter van der Westhuizen. I'm a chemical pathologist working at the National Health Laboratory Service 3 days a week. That is Tuesdays to Thursdays. So I only work 3 days a week, and the other 4 days a week I spend time on the startup, I do paragliding, I enjoy my life. So a colleague and I started this startup where we are providing software solutions to laboratories. Specifically, we write algorithms that take in laboratory data and we try and make a diagnosis for the patient. So that's the one part of our job. However, there's this challenge coming up called the Trinity challenge. It's tackling antimicrobial resistance worldwide. The prize money is quite big, I'll tell you about that shortly. We're not developers by training, we're doctors and I'm a specialist, and so is my colleague. He's actually a qualified virologist and he's now writing and studying for his exams as we speak, becoming a microbiologist as well, so he's got 2 specialities. But we want to tackle antimicrobial resistance with this challenge. Please excuse my spelling mistakes. what antimicrobial resistance is it's when a doctor gives you a prescription for an antibiotic for some infection, which is a bacteria, maybe a bacteria, most of the time it's actually a viral infection, but maybe a bacteria. They can survive some of those bacterial cells, and they will then start multiplying. And those bacterial cells that then multiply are the ones that are actually resistant to the antibiotic that's currently in your system. So that's how antimicrobial resistance starts. And it's becoming a huge problem worldwide. And I think someone has estimated by the year 2040 there won't be a single antibiotic that's currently on the market that works for any infection anymore. That's more or less what they think. And so these companies came together. I can't even name all of them, some on Google, Facebook, whatever. I don't even know all of them. They came together and they gave a whole amount of money for this initiative, which is the Trinity Challenge. So essentially what they want is they want a collaborative effort, and that's why I'm here today. I want to get you onto our team. However, you can decide to make your own team as well. You can enter the Trinity Challenge on your own. I'm proposing you join our team. We are the experts in the field. But you're really more than welcome to enter your own team, go up against us. I see all your faces, I'll know who you are. Essentially what they want is collaborative efforts, basically. So the three main pillars of the Trinity Challenge is inclusivity, collaboration, and innovation. Please, once again, excuse my spelling. And essentially what we want is a healthier future for all of us. So what we're proposing is a doctor-patient app. Now I'm not going to elaborate exactly what our idea is for that to join the team. But the essence of this Trinity Challenge is for bigger organizations whom I can't put my finger on exactly, but primarily the WHO, to get in data that what's going on with microbes on a rural level, like in Zimbabwe or in Africa or in the Eastern Cape, where there isn't actually tertiary hospitals to be able to test for antimicrobial resistance. We've got data, we've got tons of data in Cape Town and in Bloemfontein and in Johannesburg, but we don't know what's going on in the rural setting. Actually, all the research is done, even though you think it may be done in a rural setting, it's not. The data we have comes from hospitals, and where there's hospitals, there's civilization. We want data on a rural setting, right? And that's what we want to give this Trinity Challenge. So that's how we want to win it. Okay? The prize money for this is £1 million. Okay? So currently it's only me and Rowan working on the project, so we're going to split the £1 million. $500,000, I'm going to get the other £1 million, right? British pounds. Right? If you want to join us, we would consider splitting it 3 ways, 5 ways, even 10 ways. We just want to get our name on the map, basically. Okay? That's us. Take a picture and contact us. Any questions?
Which model did you use to generate those images?
Oh, yes. I wanted to go back. There was a reason there was all these spelling mistakes. Because we're not coders, I don't even know how to change Dolly's prompts to tell them, please correct your spelling mistakes. It was just GPTs.
They were very impressive.
Yeah, that's cool. Thanks. So I told them, please generate me slides.
I'm going to try and do this in such a way that I'm not going to try and follow my presentation. Any one of you, put up your hand, ever try to show something to your colleague or people that you work with that is not in your own same network, but like you run your web apps or whatever you do, and you have local hosts, and and then you don't want to use Microsoft Teams because Microsoft Teams is so cut and you can't see anything properly, like showing your screen. And I'm kind of the support role, and with the developers, I'm like the enabler, get them to work on their machine and get the stuff working. And I'm like, I just want to drive, man. I want to get on your machine and drive, and Microsoft Teams, like take control of the mouse and try and type, and it's like really slow. So what I wanted to do my presentation on is how do we securely, in under 5 minutes, create a tunnel to our computer for web application. Anyone have you ever done that before? I mean, creating certs is a bit of a mission, and let's encrypt, or creating a net or on your firewall back to your computer and your IP stream. So it's always just a nightmare. Ngrok works, but this is next level, and I love it. If you're okay with Cloudflare, but there is other ways of doing it. Okay, so caching, well, explain everything except that benefit is always if you're using Cloudflare, you get a lot of these services that come bolted on. It also gives you the zero trust ability where you can put an authentication in front of it as well. So your web app, you don't need to worry about authentication, well, in the dev environment, because you put a authenticator in front of the Cloudflare comes with an authentication mechanism where you can integrate with Google or Microsoft or some AWS stuff. And then when they come to your page for people to check out your web app or your client who's busy doing a demo, they actually they can sign in with their Google account. So then all of a sudden you're exposing your application, which is probably confidential, on the internet, but you don't have to worry about someone else getting access to it that's unauthorized. Okay, so there's a lot of benefit. Prerequisite in this demo, you need a Cloudflare account and a domain name, but you can purchase it through Cloudflare. But most of us, because we're geeks, we should have a domain name, at least one. So the thing is, you're going to just create a zero trust name on Cloudflare, and once you create that, so you click on zero trust, create a team name. Once you've done that, next step, create a tunnel, install the tunnel, which I'll show you. Let's run through this. Let's see. What do I do? Hold on. Okay. Okay, so I already have the team. You go to, I've registered this domain just for this demo, but I think we'll keep it because it's kept up forever. I think that's kind of saying I'm not planning to move. I'm going to stay here forever. Okay, zero trust. Once you click on zero trust, you got to go to access tunnels. You create a tunnel. You give it a name. Test. Now, once this tunnel is created, you get this very long token code. Then you go to the app. So this is my little app here. It's a Django, simple little app. We got something a compose file. Compose file consists of two things: the web app, or whatever you have, and in there also got a container called Cloudflare that actually pulls from the cloud. I call it the tunnel, and it's able to see the web app, but you can do SSH, database, whatever you want to expose. And as you can see, it pulls in a token from you. So if I go and open the token in here, there's a long token thing that we just added. I'm not trying to show by using one, okay?
Any accent?
Hex. How do you do this? How do you exit one? But now I can't see exit. What have I done? Install EY. I just deleted EY. Hey. I thought that was the key. Okay. And just make sure the token is right, otherwise my demo won't work properly. Okay. So that's the token. What happens is Docker Compose starts up, pulls the env file, gives the tunnel token, this long string. Embedded is the actual configuration for the tunnel. How easy is that? Once you have that running, did I not save? don't think I saved. Oh no.
The QA instead
Ah.
of W.
I did W too, yeah? You saw W. Oh, you can't see? Oh no, let me just try and zoom in somehow. How do I zoom with? You actually probably can't even see what I'm doing. Sorry. Okay, so next thing, we start up the components file. But before you start, let's look at here. We go, as you can see, no connector installed. And if I go next, you gotta give it a domain name, so let's just say demo or tennis, whatever you want. Select the domain name. This is the only tricky part. Most of you would be like, it's tunneling to the localhost, but remember that's a separate container, so you need to tunnel to the name of the container name, which is in this case would be called the container name is web. It's not to the so the tunnel will establish connection, but the tunnel is forwarding to in your internal network is to the container that you're trying to expose. Okay, very important. So then you just go save tunnel, and as you can see, that was a different tunnel. Is that a tunnel? Great, let's test. Okay, there you go. Inactive, can you see? So let's start up the containers. My web server is started up, and as you can see here, we have multiple connections with the tunnel creator. There's a web app up and running, and if we go look here, PS, as you can see, we are exposing to port 8000. Now if I refresh here, please work. Okay, so it says it's healthy, right? So we know the application should be reachable on that. Well, obviously if I type in local host 8000 application. Okay, that's expected error, but don't worry, just ignore that. Okay, and we'll fix it. So why are we having this? This is a Django error, and we know it's working. So it's just telling me that I got some issues on my allowed host. So we just is there enough time to fix it?
Go for it. You're the last talk.
I'm nervous. Okay, so let me just quickly add in here test. And what we could do is always we could do local host, right? And then you can also add that should be any subdomain. So what has happened? Okay, so Docker compose. Let's see. Everything is working. So first thing, you want to make sure it works locally before you tell someone to test. Make sure it works on your machine. Why? Oh, God. Ah, I know why. Yes. No.
Gotta build it first.
Yes. I'm trying to make this funny, okay? I know why. I knew. Okay, I'm just pretending I don't know. I'm just pretending. There you go. Come on. Woo! No fancy AI needed. Thanks, guys. It's useful, huh? Thank you.
So, good evening. My name is Mullins. I work for AWS. I'm one of the solution architects based in Cape Town. And I mostly just work with companies that's at the really start of the cloud journey. And my main job is to understand what the business problem is and then trying to help them map solutions to technology components that AWS offers. So what I wanted to actually just talk about tonight is something called AWS Amplify. So my background is in engineering, specifically electrical engineering and radio engineering, and somehow I find myself in the IT space. Who likes Lego blocks? Cool. So if you've ever sat in a corner writing some software, you know it can be really daunting. From a programmer's perspective, you're always solving problems, and usually you are reinventing the wheel, right? You're doing something that's been done hundreds of times before, just to produce some type of functionality. So one of the things that actually pulled me to AWS was this concept of using building blocks to quickly push out some new functionality. Instead of instead of me coding up how to implement some authentication system, I can just pull in a building block. If I need a queue, I can just pull it in. If I need a database, I can just pull it in without necessarily me having to go and write it, stand it up, deploy it, configure it, just push a button, it's there for me to consume functionality. So AWS Amplify is a /service /library /command line interface that enables developers, specifically front-end developers, programmers, that is not familiar with the cloud, to quickly pump out new applications, new products, quickly and easily. So this is not a sales pitch, but coming from a programmer's perspective, this kind of changes the game. So this kind of just shows some of the building blocks, I would like to call it, that you could easily consume. So if you want to implement something that just a user can chuck a data file into the browser and it lands up somewhere and your backend system can easily go and process it. It's all here. So what I want to actually show you is, let's go forward to a short little demo. This is a standard web application. This is a standard web application architecture. Okay, so something loads in the browser or it loads on a mobile phone, goes and gets data from some backend system, and then serves that data. Okay, so what we have here is your application. It's in this block. This is application. It's talking to an API, and for those that are not familiar with an API, it stands for Application Programming Interface, which allows you to perform certain actions on some backend system. Okay. Now, industry standard is typically to use a REST API, but the new kid on the block is has been the AppSync API. What that does is it allows you to basically, it gives the application power on what data it wants, instead of you having to build your logic in the back end for trying to figure out what the client wants and then goes and gets it. And then your typical database is typically a relational database, like a MySQL database. But here I'm using something called Amazon DynamoDB, which is a NoSQL database. So it's a key pair value store. It's serverless, so everything here is what we call serverless, which means you don't manage anything. You don't spin up anything. You don't necessarily configure anything. You just say, I want a database on a simple table, go and create it, and you just consume from it. So this is a very simple application, and I'll just quickly show you what it will look like to get it spin up. How many minutes do I have?
Oh no, no stress.
Okay, so what you see here is my browser, and inside of this browser is a integration development environment. So it's not actually in the browser, it's actually sitting on some server somewhere else. This is a free service. So if you ever want to get into web development in a very low-cost way, you can use this thing called AWS Cloud9, and you can go and spin up a super small, cheap virtual machine, and this IDE service is kind of free to use. So what I want to show you here is I've got a really simple. Just going down quickly. So I'm going to cd into my project. It's a very simple React application, and I'll share the links to whoever wants to run through the spin it up. Cool. So this is a really simple web application that's running in the browser on the virtual machine. Just as a matter of interest, who here are front-end developers? Show of hands. Okay, quite a bit. And the rest, back-end developers? Full stack. Okay, so I just ran this application. It's running in the browser, and what it did was, as it spun up, is, let's just see if I can do it. It loads.
Sorry, is that an extension that you have in your VS Code?
So this is not VS Code.
Xcode.
What here?
Oh,
Yeah. So here's the application. It's running in development, okay? But you want to make this thing available to the world, right? Actually, just sign it. So one of the nice things about AWS Amplify is you can pull in libraries that gives you authentication out of the box. So you don't need to go through the hassle of actually implementing authentication. So you can actually go and secure your applications. So I want to go in very simple application. We actually just sign it quickly. Okay, so here it loads. It connected to the database, and we can pull all of the to-dos that was in the database. And I was going to add another one. This is to-do number 4 from local dev. Now I'm going to create, and you can see over here. So now let's say it's working. It's a stock standard application. Just a simple create React app, install the amplified libraries, and I want to go and publish. So I've just killed it. I want to go and publish this application, and you can basically go amplify, push, and what it will do is it will take the application and it will go and deploy it in a secure S3 bucket or object storage, along with a CDN in Cloudflare. Now I've already deployed it. So if I go to my CDN, I can basically come here. So now what happened was my browser hit my CDN. It served the application, and then the application loaded, and really go and get all of the to-dos in the back end. And it was that easy and that quick. Yes?
Developing with that Cloud9
You can use any IDE you want. It's Visual Studio Code, Visual Studio.
but you must save all the code on your server.
So your code can sit. Sorry. So your code can sit anywhere. But what it did in the background is it pulled the application, it packaged it, and then it stored it on object storage in the background for it to be served to the internet.
thing that the advantage is one of using Cloud9 is that you don't have to install your SDKs locally when you use your IDE into your CLI, your database to interact with your services. And then you just use whatever functions without having to do that.
Yeah. So if you spin up the latest Cloud9 image and it uses either Ubuntu or it uses the Amazon Machine Linux image, it will come standard with all sorts of build tools, Node, whatever you typically need. So simple, but really effective when just wanting to push out new functionality very, very quick, very, very simply. Amplify also has Amplify Studio, so if you are front-end developers, you can design your front-end in Figma inside the Studio. It actually goes and generates the code modules for you that you can just basically go and pull in. And I've created a GraphQL API just by saying amplify add API, and this. I say I want a GraphQL API, which I've already added, or I want a REST API, and then just via the command line, I can go and instantiate new Lego blocks for you to consume from my web application or my mobile application.
Is there a console or dashboard where you can view all of the APIs that you created or all of the databases you created in case you want to delete like any one of them or something like that? Because from the command line, like, sometimes it's very difficult to like view everything at once compared to a dashboard where you can see like the analytics of everything.
So yes, and this shows you the DynamoDB console. If I go to all of my, so this basically shows me all of my database tables, all of my databases, but for the API. And what's really cool about GraphQL, about the GraphQL API, is that it's self-documenting. So, which am I? This one here. So you can actually come to this console, and I say I want to see all of my to-dos. Just go query, and it shows me everything that's sitting in the database. Here. And so you've got this nice development tool. You can actually go and exercise your API, which directly goes and updates your database. If you want to add new database tables, let me just show you this quickly. So yeah, one of the other cool things about GraphQL API, one of the other cool things about GraphQL with AWS Amplify is that you don't need to go and think too hard about your database schema. If you think about your standard SQL database schema, here I'm just specifying a table or a model. So here's my to-do table. It's got 3 fields: an ID, a name, which is a string, and then my description. But let's say I wanted to go and create another table, and this might be, what do you want to call it? It can be anything really. It can be cars, and we can go and save, and go out of this. Amplify. Well, so what we'll do is I've just defined a new database table, okay, to store some data, and what Amplify will do is it will go and build out that database table for me. It'll go and instantiate it, and I just need to use the API to put data in there and read it. There's no other DevOps stuff that I need to do. No other, there's so much magic going on in the background, but it makes your life easier. So and then Amplify push. So what Amplify push will do is I've just gone and built that, and now it can see. Can you see that? So it can see that there was an update made on my API, and when it makes changes on the back end, it sees that for the other resources, which is the hosting and the auth, no changes, and I need to make a change to the API. I'm going to say yes, and it will go and communicate with the AppSync service and update the new schema.